discussing the things that we can do to help fix our planet. And so, I'll hold my microphone back in its usual place soon. What we're going to be looking at is, first of all, could we end up like Venus? And the answer is no. Venus has too much carbon dioxide, 95% of the atmosphere is carbon dioxide, and also it's much closer to the sun. But it is a warning. A runaway greenhouse effect, like Venus has, the surface temperature of Venus is 460 degrees. And that is one reason that we don't say, hey, let's go to Venus, because Venus is too hot. So geoengineering is about the idea of fixing the Earth that we seem to have broken using technology. And we're probably going to have to do some of this to help bring the Earth back to cooler temperatures. Anyway, let's watch Bill Nye, the science guy. And I'm moving the audio over so that you can hear it. And I've got to switch to the other screen. Okay. All right. Let's start at the beginning.
Here, I've got an experiment for you. Safety glasses on. By the end of this century, if emissions keep rising, the average temperature on Earth could go up another 4 to 8 degrees. What I'm saying is the planet's on fucking fire. There are a lot of things we could do to put it out. Are any of them free? No, of course not. Nothing's free, you idiots. Grow the fuck up. You're not children anymore. I didn't mind explaining photosynthesis to you when you were 12, but you're adults now, and this is an actual crisis. Got it? Safety glasses off, motherfuckers.
Okay, so one of the important things from that is the idea that we might be able to fix it, but there is no free way to fix it. We have damaged things so entirely that we will have to spend resources to fix the planet. Okay, so can we fix the planet? Let's find out what possible ways we could do that with. Okay, so geoengineering is that idea of fixing with technology. And some of the ways that are proposed are that we could reflect more light away. That would help keep the planet cooler. So can we make chemical reflectors, something that can reflect light from shiny chemicals? Giant mirrors, can we cover the oceans with ping pong balls? We probably won't cover the oceans with ping pong balls, but they have talked about reservoirs reflecting light away rather than absorbing it. So anyways, there are some ideas for that. We can also try to increase algae in the ocean by giving more nutrients. And that, of course, would take carbon dioxide out of the ocean and deposit it on the bottom of the ocean. And of course, we talked about how we need to make sure there's enough calcium carbonate around for shells because that's part of that process. We can also try to recirculate the ocean. So right now, waters are stratifying, and if we could get that cold water up, that might help cool the top of the ocean. We can grow lots more trees, and then I'll show you a slide about more whales. Carbon capture and burial is where we are sucking the carbon out of the air, the carbon dioxide, and then we put it somewhere where it's harmless. And so these can work, but some have different costs and also different issues associated with it. But let's go look at a few more of these. So this reflection idea, one idea is to put giant mirrors out in space, and those would reflect more light away. So those would replace the fact that we have no longer a very good ice in the north that's reflecting. We don't have the glaciers, they're smaller. So this would help reflect away sunlight. And yeah, it's a possibility, but it's certainly not free. So in addition to giant mirrors up in space, we can have artificial trees that would suck carbon out of the air, as well as real trees. Reflective crops, so you can make the tassel on the top of the corn whiter, and that would reflect more crops away. You paint roofs of buildings with white paint, or even streets. Why do streets have to be black? Is there a possibility of having white streets, white roofs? And we want to reflect more light away. And it does cool down a city to have more reflective roofs. We can put aerosols in the stratosphere, and that will help reflect away light also. So we make it more sparkly. And we can seed the clouds to by putting salt water into the air. I'll show you that. Here's a picture. When a ship passes over the ocean, and often leaves a trail of clouds, and you can see how much more reflective this part of the ocean is because it has all these clouds across it from ships that passed by. So the idea is we would deliberately create ships that their job would be to just sail around and spew salt water into the air, creating that would be the particles needed to form clouds. Okay, so water droplets would gather. So anyway, so those are some possibilities. Fertilize the ocean, and we have algae ponds everywhere collecting carbon dioxide. We would whitewash the roofs again to reflect light. Buildings may be able to have solar panels on them. The sides of the windows might collect sunlight, and that would help to replace the energy, as well as many other innovations for architecture. Anyway, so there are lots of ideas out there. Is anything free? No, but a lot of these will pay for themselves because the degradation of our country, it will pay for itself. If we can reduce climate change, we will reduce the hurricanes again. We will reduce the damage from flooding. We will save our coasts. If we could do that, then yeah, that's actually cheap. So carbon capture and sequestration. There's the idea of taking carbon directly from the air or taking it from a factory. So a factory that is burning fossil fuels, capture the carbon right there at the power plant or the factory, and then put it down into coal seams. And that is actually already being done to help actually get more oil and methane out. But yes, you can do that. You can put carbon dioxide down into semi-permeable materials. So you can also take that right out of the air, so the carbon dioxide gets blown in to these devices, the carbon dioxide gets sucked out. And the thing is that the price has been going down tremendously. It used to be $232 to pull a ton of carbon dioxide from the air. In 2018, they said it was down to like 94. And this is great. Well, hold on, I did that wrong. So 94 to 232, but it used to be $600 a ton. So the price has really gone down. And the idea is that if we did pay $100 a ton, that would add only 22 cents for a liter of fuel. That would be about 83 cents a gallon. I admit that's a lot for people who are on a budget. So it would have to be that it wouldn't all just be on people who are driving cars, but that is how much it would add, about 83 cents per gallon. And of course, that just happened here in this country. All of a sudden, fuel prices shot up and people have to pay at the pump. But that's the idea, is that could suck carbon out of the air. So anyway, and that gas that's sucked out, they might actually make that into synthetic fuels. Okay, so anyway, if you suck carbon out, you have to decide what to do with it. So this is a picture from an experiment where they're sucking carbon dioxide out, and it's forming on these coils here and into carbon, like when you have a car or something, some of them are made of graphite sort of materials, right? Very strong. And so the idea is that, yeah, this carbon, you could build things out of it. Maybe people would build furniture. Maybe someday from IKEA, you'd get your parts that are made from sucked carbon dioxide. Okay. Anyway, so there are all sorts of ideas. Some of them are more effective, some less. Some have good cost, some are low cost. But yes, there's a lot of different things that we'll probably have to do to help the planet recover. And if anybody wants to go through this is some ideas, because some of these plans just talk about sucking away carbon dioxide. Some of them are reflecting light away. And if you only do light reflection ones, then you're not going to remove the carbon dioxide that will make the ocean acidic. So anyway, so these are sort of a debate over which ones, what are the good points and bad points of each one. And over the years, the amount of carbon that's been being put in to the cycle, so the total source of carbon dioxide and how much has been sunk, okay, the sink where it gets absorbed. And so the idea is that we used to be more in balance, but now we are less. And so anyway, so yes, the production of fossil fuels, we have too much concentration. So can we fix it? That's a good question. So this was over from 1750 to 2011. That's the total amount that the parts per million changed. But now it's changing at around 2 parts per million per year. Okay, now, is it going to ruin our economy to do something about carbon dioxide? No. There are, these were countries that worked hard to reduce their carbon dioxide footprint. From 2000 to 2014, and you can see the carbon dioxide went down in all these graphs. So year 2000, year 2014, most countries reduced their carbon dioxide footprint, but also their economies went up. So carbon down, economy up, totally doable. Even in the United States, we had a minus 6% carbon dioxide rate, but our economy went up 28%. So yeah, you can do both at the same time. This is not going to kill our economy to switch to renewables. In fact, it will provide some pretty good jobs. So what was the Paris Accord? The Paris Accord was all the countries in the world getting together and trying to figure out what to do about climate change. And they had some goals. At first, they were saying we were going to try to hold climate change to 2 degrees. But then almost immediately, they realized that that was not going to be enough. And the goal is to stay at below 1.5 degrees Celsius. So that'd be about 3 degrees Fahrenheit to avoid the worst consequences of climate change. So we're already having coral reef destruction, but if you go above 1.5 or go all the way to 2 or 3 or 4, that's definite. Also the polar ice sheet and the heat waves. So those are some of the worst things that will happen at that level or above that level. And so the idea is that it would be really good if we could stay below 1.5. Is that going to happen? It's going to be really hard. Right now it looks like, yeah, we're headed more for the 2 at best. But things are changing rapidly, some things. So this is sort of a dream idea. Could we kick the fossil fuel habit, and could we do it by 2050? So the idea is that we would be increasing solar utility scale, means have lots and lots of solar panels in a row. Could we have more offshore wind and onshore wind power? Can we have more rooftop solar? Can we have more hydropower? Now, this does not show nuclear, and I think nuclear is actually going to have to be part of our solution. It does not produce carbon dioxide. It's been used pretty safely in the United States for 60 more years. So I think we're going to have nuclear also. So things have been changing quite a bit. In 2020, renewable energy sources accounted for 12% of total fuel. So fuels like gasoline and electricity, those, it's only 12%. But for electrical generation, renewables are already 20% in the United States. Now, 20% also comes from nuclear power plant, and about 60% is coming from fossil fuels. And this is a big drop. It used to be 85% fossil fuels. So we have actually changed things quite a bit. And so we may get at least half our electricity by renewables by 2030. So that's only in 8 years. Things have been pretty incredible. And so on this graph, even though this is a dream graph, you can see that by 2020, we were supposed to have about 20% of using renewables. And by golly, we are pretty much there for electricity. Anyway, the world projected demand also, which was on the scary upward slope, has actually sort of leveled off. And so we're not using as much electricity as we thought we were going to be. Part of that is because a lot of places switched to LED lights. Okay, so actually this graph, this fantasy, is actually not that far off perhaps of where we will eventually want to be. We probably won't have kicked it totally by 2050, but we're going to have a good run here. So in the USA, as in many countries, we have been reducing our carbon dioxide level. Now, some countries are still increasing. China, you can see, has been increasing their carbon dioxide level. However, they are seriously also working on converting away from fossil fuels. So they just their economy has been boosting, and they have 1 billion people. So over the years, you can see how the renewable section has gotten larger and larger over the years, and it's expanding rapidly. This is 2016, now it's 2020, and here's another graph I need to update. Anyway, so because now it is, for electricity generation, 20%. But one of the things this graph does show you is how coal has been going down. Now, most of that was from natural gas replacing it. But yeah, we use way less coal than we used to. And in fact, fossil fuels peaked in 2006. So since that time, there has been a reduced demand for fossil fuels. And in fact, it is expected that coal definitely is going down, but also natural gas may have plateaued. So it was going up, but it may have plateaued. Nuclear is staying pretty much the same because we're not building nuclear power plants at the moment, but solar and wind are going up. Okay, so anyway, so it's very encouraging. So in April of 2019, clean energy supplied more electricity than coal for the first time ever. And so that's really incredible. Now, didn't happen always or every day. Some coal plants were down, but the idea is that, yeah, some states are doing 50% renewables regularly. So this is amazing. So solar and wind power have become so cheap to build that half the power may come from renewable energy by 2050. And that's part of the plan, right? It's not 100%, but half is great. And that's from Bloomberg. So this is not a fantasy. This is the business people talking. Anyway, so the idea is that renewables are increasing and going to continue to increase because it's become the cheapest way to make electricity is with renewables. Okay, so what we want to get away from is the oil wells and the coal seams, and we want to head towards renewables. And so let's see, this was 2017, and renewables then were up to 11% of total energy. So now they're at 12, so it's growing. But yeah, it started out really small, and it is getting larger. Okay, much larger. When you look at different states, you see remarkable differences in their energy sources. So this is going from 2001 to 2017. And the idea is what you're looking at. This is Illinois. So I've got there. These are projections for each state, or not projections. They show that Illinois in 2001, 44% of their energy came from coal, 52% from nuclear. Illinois has more nuclear power plants than any other state. And then we had a little bit of natural gas and a tiny little, well, there's not even a tiny bit of wind. We don't really start getting wind till 2007. And then by the 2017, we've got 7% wind, 8% natural gas. Coal is down to 32%. Nuclear is still stays about the same. So yes, when you're reading using light from a light bulb, it's probable your energy is half from nuclear. But it's also getting close to 10% for renewables. Okay, so different states use different amounts of things. So like in Mississippi, where they used to have mostly coal, it's now gone to 77% natural gas. In California, solar is up to 16%, hydroelectric is 20%. They've got some nuclear, they've got wind, and so natural gas is only 40%. So anyway, they've got a huge amount of renewables. And if you renewables plus nuclear is over 50%. So those are not producing carbon dioxide. In Iowa, you can see how the coal used to be 85%. Now it's down to 40. And you can see the wind has picked up to 37%. Iowa, when you travel through it, there's just mile after mile of wind tower, wind generation. And that is increasing every year. And here's Maine, which has a biomass. They burn wood in Maine, basically. That's what it is. So anyway, so each state gets their energy in different ways. But what we are seeing usually is an increase in renewables, especially wind. Here's wind again. Started at nothing when you were born. Since then, now it is 20%. So very impressive. Okay, so anyway, so all around our nation, we are increasing the amount of energy. Now, renewables and alternate energy sources are usually thought of as pretty much the same thing. So alternate energy means something other than fossil fuels or nuclear. Renewable cannot be exhausted. So something like wind will always be there. So that would be renewable and alternate. Now, hydropower is using gravitational potential energy to change to electrical energy using generators, which we'll talk about in a future chapter. Pretty much, we're not going to be building any new dams. We've used up all the best sites. In fact, there are plans, some people are saying, let's get rid of Flaming Gorge Dam, which it was terrible that they took away this beautiful canyon. And now this water that's piled up behind it is much lower and is needed down in Lake Powell. So anyway, but dams also have the problem in that fish can't get up despite fish ladders, and also oxygen is depleted behind them. So dams are not benign. They actually do cause issues for a river. Nuclear is a possibility. We may get tiny little nuclear power plants. They're about as big as a house, turned sideways. And these tiny little ones might be used to run small towns. And so you wouldn't have so they would build fewer big ones and more tiny boutique style nuclear plants. And these would be much less dangerous, being much smaller. But you can see how Illinois has a lot, or 10 or 11 nuclear power plants. Okay. Now this chart's a little old because it's 2016, but you can see how the price of um, wind and solar was less than coal. And that is one reason that nobody wants to build a new coal plant, and they can't get financing for it either because banks are actually listening to people about climate change. So anyway, so no new coal plants will be built probably, but what we will have is lots and lots of new wind and solar facilities. Now, wind power is just doing great. It's being built in so many places. And of course, you need to have it somewhere where there's a lot of wind, but the United States has a lot of wind. It has very few environmental effects. People do say it kills birds, but so does tearing down a forest. And they found they can just paint one of the blades a different color, and that's helping a lot. And people have used them for thousands of years. Some people don't like their looks, but you know what? Let's save the planet, then we'll worry about how it looks. Right now, America has over 52,000 grid scale, so big, wind turbines. And in fact, that number is a couple of years old, so it's probably closer to 60 or 70,000 now. And so where would you put your wind power? Well, you can see that these states are pretty darn windy, right? Of course, other places you would put it is off the coast. The darker the green, the windier it is. And so anyway, so there are lots of places where we might put wind power instead of the ugly oil rigs, right? So California has had to put up with ugly oil rigs that were put in the 50s, and they haven't been able to get rid of them. But maybe we can now. So anyway, this is just a picture of the original first electricity generating wind tower in Cleveland, Ohio. It was 60 feet tall, had 144 blades, generated 12 kilowatts of electricity. That would power about 3 modern homes. If we take one of these wind turbines, they're about 650 feet tall, and they can produce 2.5 megawatts. That's millions of watts, whereas this was kilowatts, thousands of watts. And that's enough electricity for 500 homes. So one generator generates energy for 500 homes. So this is pretty incredible. And here's some numbers. Okay, so 1 megawatt of power provides for over 200 homes. A gigawatt of power would provide for 200,000 homes. So a gigawatt is a billion. Megawatt is a million. And a wind tower is a little shorter than the Eiffel Tower, but taller than Big Ben. Okay. Now, what state has the most wind generation? It's Texas. Texas has more wind turbines than any other state. So this is megawatts of power. So they have 21,000 megawatts of power. And remember, each megawatt provides energy for about 200 homes. So that means that what we've got here is 4 million homes provided with energy. If I did the math right. Okay, so anyway, so about 4 million. And then it works in Texas because you can still have fields underneath, you can still have cattle. You don't usually want it right next to homes because they do make a sound. So, but it works great out on the prairie in Texas. This is Indiana. If you've driven down to Indianapolis, which there is going to be an eclipse in a few years, so it'll pass through Indianapolis. Maybe you'll pass by this beautiful wind farm that stretches out on either side of the road. Here's some wind power in Vermont. Here's some in California, which usually improves the look of the hills. And here's some in Hawaii and in Germany. Okay, so anyway, so wind power everywhere. And the thing is, what about in the ocean? Can you have the wind generators off the coast? Well, yes, you can. And it's the United Kingdom has more wind turbines than anybody else, at least in May of 2017. It also has a lot of offshore wind farms. And some of these are close to the shore, so they're standing on shelves of rock underneath. They're still located in the mud. Some of them are in deep water, floating off the coast. And so yeah, so 12,000 megawatts of power in Europe. There are 3,500 wind turbines. Okay, and an offshore, the United Kingdom is the leader. So 36% belong to the United Kingdom. Okay, now, and this is a cool picture. Now, what about in the United States? Well, there was a wind farm proposed in that nice windy area up here on the East Coast, and it was proposed to be around Cape Cod and Martha's Vineyard and Nantucket, big tourist areas. And so some people objected. And some people said, yes, let's do it because they were for the environment. And some people said, no, let's not do it because they were for the environment, but they wanted it to stay pretty. And people were worried about their fishing grounds and other stuff. And there were a lot of rich people here who wanted to look out and didn't want to see a wind turbine. So after 16 years, the lesson learned was don't build too close to shore where people will object. So they're going to try these big floating platforms out deep in the water. And first of all, they put the only offshore wind farm in the US in 2016. We have 5 whole turbines, 30 megawatts. Anyway, so this one is hidden behind an island where no one can see it. But the idea is, yeah, maybe if you put them further offshore, people will find them more acceptable. However, President Biden has come in and he is proposing again. They're going to pass and they're going to put this wind generation in place. So we might see that coming up. Another thing that Biden did is he put there's a testing ground off the coast of Oregon, which has cables and stuff where you can test your different devices out at sea, because that was one of the problems. How do you test things when there's ships that run around? So they made a spot where people could test things out in the ocean, like tide generators and stuff like that. Okay, so anyway, so there are big wind generators. Now, what about how do we store energy? That is actually going to be one of the main issues, one of the things that we're going to look at today too, because we're going to be looking at solar power and storage. So let's take a little break and come back and look at solar. All right, let's stop recording.